Hello. We will now discuss paper 4 of variant 1 in 2023 October-November series. The first question that we have here is a question related to transformations, transformation of shapes. So then in this question, describe fully the single transformation that maps shape A onto shape B. So shape A onto shape B is what you need to describe what really happens there. So it has been translated. So this shape has moved onto this shape B, means if it moves that way, so then it means it's been translated. So you need to mention the type of transformation it is. So it's going to be translation. And if it's translation, you need to mention its column vector. So in the right side of the screen, I have mentioned the types of transformations that we have. There are 4 types. And in yellow, I have written what to mention when you describe it. So when it comes to translation, it's very important that you mention the column vector. So it's translated. So we can write it as translation by a column vector of, you're going to identify the column vector. The column vector will explain how many units you're going to move up or down, or to the right or left. So then the movement across is mentioned at the top. So this point here has moved 1, 2, 3, 4, 5, 6, 7 units to the left. And from there, we have moved 1 unit down. So 7 units and 1. But as it moved left, it will be -7. And as it moved 1 unit down, it's going to be -1. So this is how the column vector will be written. Part B, second part, shape A onto shape C. So shape A onto shape C. So this is shape A, this is C. In this case, this is not translation or reflection. This is something to do with rotation. So shape A onto C means this A has been translated onto C. So when it comes to rotation, we need to mention the angle, the direction in which it has been rotated, whether it's clockwise or anti-clockwise, and the center of rotation has to be mentioned. So in this case, we can clearly see that we know the name of the transformation, which is rotation. It is rotated in the clockwise direction, and it looks like it has been rotated by 90 degrees. And yes, it is rotated by 90 degrees. But you need to find the center of rotation. So to do that, you need to make use of a tracing paper. So you can do the same thing by using a pair of compasses, or you can even make use of a protractor to figure the angle. But the best way to do it is to use a tracing paper. So you're going to place the tracing paper on the grid like this. You're going to draw the object, which is A, and then you're going to select different points on the grid. You're going to place the pencil point and you're going to start rotating the tracing paper so that the object that you have drawn, the diagram that you have drawn on the tracing paper, coincides with the object, the image in the image C, with this shape C. That is how you identify. You repeat it until you find the center of rotation. So in this case, when we do that, the center of rotation will be at 5, 1. This is what the center of rotation will be. Then we are going to write what is done there, what happens there. So rotation by 90 degrees clockwise about the point 5, 1. This is the center of rotation. So rotation, the angle, direction, and the center of rotation has to be mentioned. In question C, on the grid, draw the image shape A after a reflection in the y is equal to 2 line. So y is equal to 2 line is the straight line that goes through 2 in the y-axis. So this is going to be that line. This line is going to be called as this line that we have here is the line of reflection. Now, Shape A has been reflected. Shape A is the one that is at the bottom. It has been reflected about this line that is given here. Then in that case, we need to see where the image will be. So each of these vertices in this triangle that is given to us, you need to see how far away it is from the line of reflection that is given, and then we can mark the image. So it is 1, 2, 3, 4 units away. This is 4 units away. You do the same distance in its opposite sides. It's going to be 4 units away. This point will be here. This point is 6 units away from the line of reflection, so that will be here. Now we're going to connect this to draw the image. So this is how the image will be for question B1. In question B2, shape A after an enlargement and the scale factor is given as -2, the center is 0, 0. When you explain, or when we describe enlargement, there are 2 points we need to mention: the scale factor and the center of enlargement. In this case, the scale factor and the center of enlargement is given to us. We need to find where the image will be. So first, the center of enlargement is given as 0, 0, which is the origin. So I'm going to mark the origin. So this is that origin. And now you need to see that it has been, you need to understand that it has been enlarged by a scale factor of -2. This negative explains that it has been enlarged in the opposite direction. So this is what you need to understand because when we see this negative for a scale factor. So the first step to do is we're going to draw straight lines that pass through this center of enlargement and the vertices of this triangle. So first I'm going to draw this point. I'm going to draw a straight line that goes through the shape like this. This is how it's going to be. So once when I draw that, I'm going to see how far away this point is. This is from the center, so it's 2 diagonal boxes away. So I'm going to do the same thing, but as the scale factor is -2, from the center of enlargement, I need to make 2 jumps of that same distance, which will bring the point here. We repeat the same thing for the other vertices as well. So I'm going to draw the vertex for this point here. So then when I draw the vertex that connect this point and that goes through this, this is how it will be. That goes through the center of origin. This is how it's going to be. Now I'm going to do the same thing again. So I'm going to see how far away it is. So this is like about 4 diagonal units away. So then you're going to do that same distance. We're going to do it twice. So this is where it's going to be once from the center of enlargement. Then you repeat it. So this is where the next point will be. So as the scale factor is -2, it has to be marked here. Then we do the same thing with the other vertex as well. So this is the next vertex given. So we are going to draw a line like this. So this is how the line will be. And now I need to repeat the same process again. So this distance is like about 3 diagonal units away. It looks like that. It's not exactly that amount, but almost like that. So the same distance, I'm going to repeat it. So 1, 2. So from the center of enlargement only, we need to calculate, we need to see what that scale factor is going to be. So then this is where that vertex will be. Now we are going to connect this to form the shape. So this is where our image will be. Let's move on to the next question that we have. That is question 2. We need to find the value of S now we need to find the value of S. A and T is given to us. Simply you substitute it. So half times A is 9.8 times. T is 20. You need to square that up. We need to square that to find what S is. So when we put this in the calculator, we can get the answer as 1960. In the next question, we need to expand this and find what y is because we are asked to solve. So this is an equation. So first get rid of the brackets that we have by multiplying the terms inside the brackets with the number outside. We get 20y minus 15 is equal to 15. I'm going to bring this positive 15 to the other side, that negative 15 to the other side, it becomes positive 15. So this is 20y is equal to 15 plus 15 becomes 30. Now I need to bring the 20 to the other side. So I need to divide it by 20. So that is how I bring the 20 to the other side. So the value of y is equal to 3 over 2, which is the same as 1.5. That is what y is equal to. In question C, we are supposed to expand the brackets here and simplify. So 3 times 5x will be 15x. 3 times negative 8 is negative 24. Negative 2 times 3x is negative 6x. Negative 2 times negative 7 is positive 14. We will combine the like terms. So the like terms are 15x and minus 6x, which becomes 9x. Then I have minus 24 and plus 14, which is the same as minus 10. In question D, we are supposed to make C the subject of the equation that is given to us. So we have A is equal to 2b squared minus 3c cubed. I'm going to make C the subject, means I need to isolate C. I'm going to bring this minus 3c squared to the left side of the equation. So that becomes plus 3c, it's not squared, I'm sorry, it's cubed. So this is equal to 2b squared. I now will bring A to the other side. So 3c cubed is equal to 2b squared minus A. Now with the c cube, I have 3. I'm going to remove this 3. The 3 is multiplying with the c cube. So if I'm to get rid of that 3, I need to divide it by 3. So c cube is equal to 2b squared minus A. This entire thing, everything in the right side should be divided by the 3. Now that is equal to c cube. If I'm to find what c is, I need to do the cube root of the answer that I get here. So I need to do cube root because we have a cube here. So this is 2b squared minus A, and this is over 3. So in question E, there are 4 terms. We need to factorize it. To factorize when we have 4 terms, I'm going to pair this. In the first pair, I can take the highest common factor out, which is 2 and q. I'm going to put the rest inside the brackets, which is 3p minus 2. Next, I'm going to take minus 1. So we have 3p plus 2, 3p minus 2, because we have taken the negative out. So the terms inside the brackets should be written once, and the terms outside the bracket should be combined together, put together and written in the next bracket. So this is what we get as the answer. Let's move on to the next question that we have. In question 3a, we are given a table with distance and the average distance from the sun of 5 planets. And then the first question that we are asked to do is the average distance of mass from the sun is 2.279 times 10 to the power 8 kilometers. Write this distance as an ordinary number. So we need to write this as an ordinary number. Ordinary number means we need to get rid of all the powers, the 10 to the power 8 should be completely removed. So in that case, to get rid of that, this decimal point that we have here has to move 8 times to the right side. The reason why it has to move 8 steps to the right is because we have 10 to the power of 8. It becomes 8 times larger. So then when it moves that way, we end up getting 2279, and we have 1, 2, 3, 4, 5 spaces. So we are going to fill that with zeros. So this will be our answer. And in part B, the second part that we have, planet Uranus has a diameter that is 35.8% of the diameter of Jupiter. We need to calculate the diameter of Uranus. The diameter of Jupiter is given to us as 143,000. So 35.8% means, so 35.8 over 100. I'm going to times this with the diameter of Jupiter, which is 143,000. So when I do this, I end up getting 51194, 51,194 kilometers. This will be the diameter of the planet Uranus. Let's move on to part 3. The ratio the ratio diameter of Neptune to a diameter of Saturn can be written in the form 1 to n. Find the value of n. So this is again relating the diameters. So it's about Neptune and Saturn. So the diameter of Neptune is given to us as 49,500. So I'm going to write it here, 49,502. The diameter of Saturn is given to us as 120,500. So 120,500 is what's given. And we need to write it in the form 1 to n. 1 to n means for Neptune, the amount that is given to us should be made into a 1. So to make this 49,500 into a 1, we need to divide this by 49,500. We do the same thing to the other side as well, that is to divide it by 49,500. So when we do that, we end up getting the answer as 1 to the value of n. So now to find the value of n, I'm going to put 120,500 divided by 49,500. So when I do this, I end up getting 2.4343. Likewise, it keeps continuing. So I can write it as 2.43. So correct 2 decimal places, I have written it. So that means the value of n is 2.43. In question 4, find the average distance of Neptune from the Sun as a percentage of the average distance of the Earth from the Sun. So that is, the distance of Neptune from the Sun over the distance of Earth from the Sun should be written as a percentage. So we need to multiply this by 100. So the distance of Neptune from the Sun is given to us as 49,500. So I'm going to put that 49,500 in the numerator. And the distance from the Earth to the Sun, that is actually the diameter that I picked. It should be the average distance that I need to pick. So the average distance is 4.495 into 10 to the power 9. 4.495 into 10 to the power 9. And for Earth, we have 1.496 into 10 to the power 8. And then we need to times it by 100 to convert it into a percentage. I can cross out 10 to the power 8 with 8 tens in this 10 to the power 9. So we will be left with 1 10 there. And now I'm going to put the rest in the calculator. So I'm going to put the fraction here, which is 4.495 times 10 over 1.496. And then I'm going to times it by 100. So this will be equal to 3004.679. So correct 2 decimal places, I can write it as 3004.68. So this is equal to 3004.68%. This is the answer. Let's move on to question 5. Distances within the solar system are also measured in astronomical units, AU. The average distance of Jupiter from the Sun is 5.20 AU. Calculate the average distance of Mars from the Sun in astronomical units. Now, we're going to do this question like working out questions where currencies are involved. Exchange rates of currencies are involved. So, for Jupiter, the distance is given to us as 7.786 times 10 to the power 8. So 7.786 times 10 to the power 8. And this distance, which is given in kilometers, is the same as 5.20 AU. So this is the same as 5.20 AU. Then this is for Jupiter. Then we need to calculate the same thing for Mars. And the distance there was given as 2.279 into 10 to the power 8. We need to convert this into astronomical units. So I'm going to label this as X because that is what we are supposed to find. We have 2 equations. You need to find what X is. We simply cross multiply and make X the subject. So in this case, I will have 5.20 times 2.279 times 10 to the power 8 in the numerator. And in the other side, now I can like directly put this in the numerator and put this 7.786 times 10 to the power 8 in the denominator. Or I can say that this is equal to this 7.786 times 10 to the power 8. So 7.786 times 10 to the power 8 into x. If I'm to find what x is, I need to write 5.20 times 2.279. I need to times it with 10 to the power 8 and then divide it by this amount that I have here, because I'm going to take this amount to the other side of the equation. So divided by 7.786 times 10 to the power 8. So when I do the division here, I will get the value of x, which is the average distance of Mars from the Sun. And in this case, the distance will be given in astronomical units. So when we do this, when we put this in the calculator, we'll get the answer. So which is equal to 1.52 astronomical units. This is the value of x. In question 6 that is given here, the diameter of Mars is 39.2% greater than the diameter of Mercury. Calculate the diameter of Mercury. So this means that if I'm to write it, if I'm to just do a small make a small note here, it's going to be this way. Mercury, we have Mars here, and in this case, it's dealing with the diameter of the planets. So the diameter of Mars is given to us as 6,800 kilometers. And we need to, now we have 39.2% greater. If it's 39.2% greater means it increases by 39.2. So we need to find the multiplier by adding that with 100. It becomes 139.2%, which is the same as 1.392. So I need to find the multiplier like this. So it's going to be 1.392. But the starting value is what I'm supposed to find. So this is what I'm supposed to find. In that case, this 6,800 has to be divided by this multiplier. If the distance of Mercury is given and you're supposed to find the distance of Mars, in that case, the distance of Mercury has to be multiplied by this 1.392. So in this case, we will have to do the division. So when we do the division, we have 6,800. I need to divide it by 1.392. So when I do this, the distance that I get here will be the answer. So 6,800, I'm going to divide it by 1.392. So this is equal to 4,885.06, which is correct to 2 decimal places. So 4885.06 astronomical units. This is what we get. Question B. 1 light year is the distance that light travels in a year of 365.25 days. The speed of light is given to us. That is given in kilometers per second. That is the distance it travels in a second is given. Show that 1 light year is 9.461 times 10 to the power 12 kilometers, correct to 4 significant figures. So in this case, now here, we know that the distance traveled in 1 second is given to us as 2.9979 times 10 to the power 5 kilometers. This is the distance traveled in 1 second. We need to convert the distance traveled in 1 second into the period of time, which is you need to find it in years. You need to find how far it will travel in 1 year. That means first we're going to convert the seconds that we have here into minutes, then into hours, then we will convert it into days. Then once when we know the number of days, when we convert it into 1 day, then in that case, we can easily convert it into 365.25 days. So then what we got to do is, now in this case, it's given in seconds. So we need to convert it into light year means we got to do the division here. So then this is what we have. So I'm gonna do the division then. So I'm gonna divide this answer by 60, 60, 24. So this will give us the number of days. And then I need to divide it by this 365.25 days, because we need to see in 1 year how far it travels. So we're going to do this so that we can see what we end up getting. So let me put this in the calculator. 2.9979 times 10 to the power 5. So 10 to the power 5. So let me get rid of that extra box that we have. Power 5. And then we need to divide it by 60 times 60 times 24 times this amount. So this is what we end up getting. One light year is the distance that travels in a year of 365.25 days. So the speed of light is given to us. So this is given in kilometers per second. So that is, it's the distance traveled in a second is given. Show that 1 light year is 9.461 times 10 to the power 12 kilometers, corrected for significant figures. So you need to show what 1 light year is equal to. So this is the speed of light per second. So per second has to be converted. This is given to us in seconds. So you need to find how long it will be in a year, in 1 year. So then in 1 year, we need to see how long, how much it's going to, how long it's going to take. So then in that case, now this is for 1 second. So 2.9979 times 10 to the power 5 is for 1 second. Then when it comes to when it comes to a minute, I need to times this by 60. I need to times it by another 60 to check the distance traveled in 1 hour. Then again, I need to times it by 24 to check the distance traveled in a day. Then I need to times this by, I wouldn't be timesing it by 365, but 365.25, because that is how it's mentioned in the question. So this is what I need to do. I'm going to multiply them all together and see what we end up getting. So then I'm going to put this in the calculator. So I have 2.9979 times it with 10 to the power 5. And then we got to times it with 60, another 60, then 24, and then we have 365.25. So when we multiply them all, this is what we end up getting, which is 9.4606.5, but we need to write it correct to 4 significant figures. So it's going to be 9.461 times 10 to the power 12. So this will give us 9.461 times 10 to the power 12 kilometers. This will be the answer. Let's move on to question 2. The distance from the Andromeda galaxy to Earth is 2.40 times 10 to the power 19 kilometers. Calculate the time taken for light to travel from this galaxy to Earth. Calculate your answer in millions of years. This is very important. Now, we already know in the question it's mentioned that in 1 second, light travels 2.9979 times 10 to the power 5. 10 to the power 5. So this is what is given to us. This is given in kilometers. Now, we need to see to travel this distance, which is 2.40 times 10 to the power 19 kilometers. We need to see how much time it would take. So we're going to label this with a variable like x. So 1 second, this is how much it's going to travel. You need to find how long it will take to travel this distance. And now what I got to do is, just like solving equations, I'm going to cross multiply this. So when I cross multiply this, I get 1 second times 2.40. So 1 second times 2.40 times 10 to the power 19. This is equal to x times 2.9979 times 10 to the power 5. So if I'm to find what x is, I need to take this to the other side. So to take it to the other side, it has to be divided. So I can forget about this 1 for now. So because when we multiply it with 1, it doesn't make a difference. So 2.40 times 10 to the power 19 is divided by 2.9979 times 10 to the power 5. This gives us what x is. So now this answer that we get here is going to be in, now we're going to first see what we end up getting here. So we will calculate that first. So we have 2.40 times 10 to the power 19. We got to divide this by 2.9979 times 10 to the power 5. So when we do that, this is what we get as the answer. This is going to be in seconds. This many seconds, this is how many seconds it will take. But then the answer that we get here, I'm going to convert it into, we need to convert it into million years. So to do that, I need to divide this answer that I get here. The answer that I get here has to be divided by, so I will write the answer here in the side as 8.0056. Likewise, we have an answer. That answer times 10 to the power 30. This is given in seconds. I need to convert it into million years. So I need to divide this answer that I got here by a 60 to convert it into minutes, 60 again to convert it into hours, by 24 to convert it into days, and by 365, not 365.25, but 365 to convert it into years. But then we need to convert it into million years. So as I'm to convert it into million years, again, I need to divide this by a million, which is the same as 10 to the power 6. So I'm going to do this calculation. I'm going to do the division here and see what I end up getting. That will be the answer in million years. So this answer that we have here, we need to divide it by, I'm going to put it within the brackets, everything I'm going to put within the brackets. I have to divide it by 60 and then another 60. And then I had to divide by 24 and then 365 and then a million, which is the same as 10 to the power 6. So I got to do the division here. So this is what I end up getting. 2.5385. So this many million years. So I can write it to about 2 decimal places as 2.54 million years. So 2.54 million years will be my answer. Let's move on to the next question. Question number 4. This is a question which is about probabilities. So Lucia has 2 felt spinners and the outcome of each spinner is given to us. The first spinner, which is A, is 5-sided and the next spinner is 9-sided. And we need to complete the tree diagram. So spinner A's outcome is written and they have split this into 2 as prime and not prime. So getting a prime number from spinner A is going to be 3 out of 5 because the prime numbers that we have here is 1, 3, and 5. Not a prime number will be the remaining 2. So that's going to be 2 over 5. In the second one, getting a prime number, which is spinner B, getting a prime number is, we have the 3's and then the 5s. So there are five numbers there, 5 out of 9. So not prime will be 4 over 9. So this will be the same thing here, 5 over 9 and 4 over 9. This is what we have. The first question that is given to us after this tree diagram is that we need to calculate the probability that the two numbers are both prime. Both are prime means this is also prime, this is also prime. Prime and prime. So the two probabilities that we have written in the branches are 3/5 and 5/9. We simply multiply them together. So 3/5 and 5/9 we multiply together, and we can simplify. So I can cross out this 3 with the 9 by dividing both by a 3. So I get a 3 here. And I can cross out this 5 with this 5 because they both are divisible by 5. So I get 1/3 as the probability of getting two numbers that are both prime. The next one is the two numbers that are not both prime. The two numbers are not both prime. So both prime is 1/3. Not prime, both the numbers are not prime means it's going to be the opposite of this. In that case, it's going to be 2/3. So from 1 whole, you need to deduct this 1/3 that we found in the previous step, which will give us that 2/3. Let's move on to the next question that we have. Lucia spins spinner A 120 times. Find the expected number of times the spinner lands on prime number. So it has to land on a prime number means. Now, for spinner A, the probability of getting a prime number was given to us. We found it as 3/5. That was already given to us in the question. So then this has to be multiplied with this 120 to find the answer. When we do this, we get 72. So that means the spinner lands on a prime number 72 times. This is the expected frequency. Then the next question, Lucia spins spinner B twice. Find the probability that the two numbers it lands on add up to 9 or more. In this case, the same spinner is spun twice. In spinner B, we have 3 3s, 4 4s, and 2 5s. So then, the same spinner is spun twice means, now we need to find the total number of outcomes we will end up getting. So to find the total number of outcomes, what we got to do is, in the first event also, we will have 9 outcomes. Second event also, individually, when we check, we will have 9 outcomes. So the total combination it will make will be 81. So when we write the probability, it has to be written out of 81. And in the spinner, we need to make sure that the two numbers that we end up getting from both the events when we spin spinner B twice, the outcomes should make a total of 9 or more. So we need to check what possible combination can be used to get a total of 9 or more. It can be a 4 in the first spinner and a 4 in the first event and 5 in the second event, or else it can be a 5 in the first event, 4 in the second event, or it can be 5 in the first event and 5 in the second event. But this happens using the same spinner because the same spinner is only spun twice. Now, in the spinner B, we have 4 4s, which means you will have 4 4s and we have 2 5s. So those two should be multiplied together. So you get 8 such combinations. And we have 2 5s and 4 4s. So we multiply them. So we still get 8 combinations of getting a 5 and a 4, which makes a total of 9. Then you will have 2 and 2 because getting a 5 is also 2. Getting another 5 is also 2. That's because in the spinner, we have 2 5s in spinner B. So this makes a total of 4 such combinations. We need to add them all up, which makes a total of 20. So the probability when we write, it should be written as 20 out of the total number of outcomes, which is 81. Let's see what is given here in question D. In question D, Lucy keeps spinning spinner B until it lands on 4. So that is the last time is when when it lands on 4. We need to find an expression in terms of n for the probability that this happens on the nth spin. That means before it lands on 4, she has tried several times. So she has tried several times before it lands on 4. So to find the probability for this one, landing on 4, the probability is 4/9 for spinner B. Before this, it does not land on 4 means it's going to be 5/9. But she would have tried several times. So due to that reason, we would write it as to the power n-1. The reason why we deduct 1 is because in this case, we have another term that follows after trying it several times, which ends up giving us this 4/9. So this is going to be our answer. Let's move on to the next question, which is question number 5. This is a question related to trigonometry. So the values are mentioned here. We need to calculate the angle ACD. So ACD is this angle. To find the value of this angle here, I need to first find what AB is or BA is. So for this angle that is given to us, this side is the opposite side and this side is the adjacent side. So the trigonometric ratio that involves the opposite side and the adjacent side is tan. So then that is, we can use SOHCAHTOA for this. So in that case, it's going to be TOA, which is tan. So then tan theta will be equal to the opposite over the adjacent side. In that case, it's going to be 83.2 over the adjacent side. I'm going to label that as AB. But this angle is known to us as 38. So instead of writing it as tan theta, I'm going to write it as tan 38. So to find what A is, I'm going to switch these two places. So then when I switch the places, AB is equal to 83.2 over tan 38. So we can put this in the calculator and see what we get as the value for AB. So then 83.2 has to be divided by tan 38. So when we do this division, we end up getting 106.49. So I can write it here as 106.49. So this is going to be 49 meters. This is going to be the distance from A to B or B to A. The reason why we had to find this is we need to add this with this 54.5 because that will give us what AC is. When we find that, the value of AC will be equal to 106.49 plus this 54.5, which will be equal to 160.99 meters. Now, I'm going to apply tan theta again using this larger triangle that is given to us because we now need to calculate the angle. So in that case, the opposite side that we used previously will stay the same. This time, the adjacent side will be this complete length, which is that 160.99 meters that we found. So again, we're going to apply tan theta here. The adjacent side is known to us, which is 83.2. And the denominator, which is the opposite side is known to us, 83.2. And the adjacent side, which is 160.99 is also known. We're going to put that here. But in this case, we're supposed to calculate the angle. So we need to do inverse tan for the value that we have here. So 83.2 over 160.99. So I'm going to put this in the calculator. So inverse tan is what I need to use when finding the value of the angle. So in this case, so it's going to be 83.2. I need to divide it by 160.99. So when I do that, the value that I end up getting will be equal to 27.33. So this is the value of the angle. So the angle is 27.33 degrees. Let's move on to the next question. In this question that is given here, we need to mark, a circle can be drawn that passes through these three vertices, which is F, E, G. On the diagram, mark the position of the center of the circle with a cross. Explain how you decide. The cross has to be marked in the middle of this point here. So it should be here. So this is going to be the center because only then these two sides will be equal. The reason why this is going to be the center of the circle is this is using the circle theorem. So when we use the circle theorem, in a semicircle, when we draw an angle like this, if an angle is subtended in a semicircle, then it will always be 90 degrees. Already they have given that this is a 90-degree angle, and it clearly states that all three vertices will touch the circle, just like in this diagram that I have drawn here. That's the reason why we were able to mark the point right in the middle of this line, FG. So I can write the reason as it's the angle in a semicircle. I can write it as angle in a semicircle is 90 degrees, or is always equal to 90 degrees. This is the reason. Let's move on to question C. In this question, we are given a triangle which is LMN, and the other triangle is PQR. In triangle PQR, the values are, the side lengths are given to us. And in this triangle, the ratio of the angles are given to us as 4 to 5 to 6. So angle L to M to N is given as 4 to 5 to 6. This is how it's given. Calculate the difference between the largest angle in triangle PQR and the largest angle in triangle LMN. We need to calculate the difference, and it should be between the largest angles in both the triangles. In this case, we have 4 to 5 to 6, so the largest angle will have the largest value. So then it's going to be 6, but then that's not the angle, this is the ratio. So we need to calculate the angle that it makes. So here we have 4, 5, and 6, which makes a total of 15 parts. So 15 portions of 15 parts. So 6 parts of that is for angle N. So to find the value of angle N, which is in this angle that we have here, we need to write 6 over 15. We times it by 180 degrees because the angle sum of a triangle is equal to 180. So when we do that, we get 72 degrees. This is the value of this angle that we have here. We got to do the same thing for this triangle as well. So in this triangle, the largest angle is always the angle that is opposite to the longest side. So it is 6 here, which is the longest side. So this will be the largest angle, which is angle R. If we are to find this angle R, in this triangle, 3 sides are given to us. We need to calculate the angle, so we definitely go with the cosine rule. So according to the cosine rule, we have a squared is equal to b squared plus a squared is equal to b squared plus c squared minus 2bc cos a. This is how it's given. In this case, this a and this a are right opposite to each other. So that is, this a represents the angle, whereas this a represents the side that is opposite to the angle. In this question, according to this diagram, this angle A has to be angle R because that is what we are supposed to find. This angle A will be this 6 centimeters that we have because that is the side that is opposite to this angle. So we need to substitute it as 6 squared is equal to, we can label B as 4 or B as 5 as well. There's no problem with that. So I can just substitute it as 4 squared plus 5 squared minus 2 times 4 times 5 times cos of A. In this case, I'm going to change it to R. So we need to find what this R is. So I'm going to rearrange this equation to isolate R. So I'm going to take this negative term that I have here to this side and this 6 squared to this side. So it becomes 2 times 4 times 5 times cos R, which is equal to 4 squared plus 5 squared. And the 6 squared comes to the other side. It becomes minus 6 squared because it was positive when it was in the left side of the equation. I need to find what R is. So I'm going to isolate cos R first. So cos R is equal to 4 squared plus 5 squared minus 6 squared. I need to divide it by this 2, 4, and 5 because these 3 are multiplying with this cos R. So when I take it to the other side, it has to get divided. This will give us what cos R is. I need to find what R is. To find R is an angle. So in that case, I need to do inverse cos for this entire expression that I have. So I'm going to directly put this in the calculator. So inverse cos of this expression that I have here, which is 4 squared plus 5 squared minus 6 squared. And then I need to divide it by 2 times 4 times 5, and I need to close the brackets here. So the answer that I get is 82.82 degrees. So in this case, the answer is the value of R is 82.82 degrees. The question is asking for us to calculate the difference between the two largest angles, angle in both the triangles. So I need to find the difference between these two. So from 82.82, I need to subtract 72, which is equal to 10.82 degrees. This is the difference between the two angles. Let's move on to the next question that we have. In question 6, there are 3 different sequences given to us. We need to find the 5th term and the nth term, the formula for the nth term. In this case, when we consider the first sequence that is given to us, we have -7, -3, 1, 5. Likewise, it keeps continuing. Each time, when we check this, each time it increases by 4. As it increases by 4, this is the difference between the numbers that we have here. Each time it increases by 4. So in this case, we can form the first part of the nth term, which is going to be 4n. And also, as we know that we have a 4 here, we need to see how much more should I add or deduct to get to this -7. In that case, we need to deduct 11 from this 4 to get to this -7. So this -11 that we deducted gets combined with this 4n. That will be the nth term for this sequence. And this sequence that we have here is an linear arithmetic sequence. It increases by the same amount. Now we are also supposed to find what's the 5th term. That will be 4 more than this 5. So in that case, I need to add 4 to this 5, which will be a 9. Now, the second sequence that is given to us is given as 7, 13, 23, 37. Likewise, it keeps continuing. So when we find the difference between the terms here, 7 to 13, there is a difference of 6. It increases by 6, then by a 10, and then by a 14. Here, the amount by which it increases is not the same, not the same. But in the previous one, it was a constant value. Here, it's not a constant. It's not a fixed value. This is when we understand. This is how we need to understand that this is not going to be an arithmetic sequence like this one. So we're going to find another difference as well. We're going to find its second difference. This is the first difference. First difference is not the same. We're going to find the second difference. When we find the second difference, we get a 4. For this, it increases by a 4. This also increases by a 4. Here we know that the second difference is the same. This is when we understand that this is a quadratic sequence. When it's a quadratic sequence, to find the nth term, we can use this, we need to find the formula so that it's in the form an squared plus bn plus c. So we're going to pick the first 3 numbers that are given here. The last number, you need to relate it with the last equation that we have, which is 2a. This number here, that is this 6, you need to relate it with the second equation that we have here, which is 3a plus b. And this 7 is related with this a, b, c. So we need to equate it this way. And now we need to find what a, b, and c is according to these 3 equations we have. So first I need to find what a is. To find what a is, this 2a is equal to 4. So if 2a is equal to 4, the value of a is equal to a 2. This forms the first part of the nth term. Now the nth term equation is given as an squared plus bn plus c. So here the value of a is 2. So I can write it as 2n squared. I now need to find what b is. I know what a is. So the second equation is 3a plus b is equal to this 6. So I'm going to substitute the value of a here, which is 2, plus b is equal to 6. 3 times 2 is a 6. 6 plus b is equal to a 6, which means the value of b has to be a 0. In this case, this part will be 0n or 0. So I can just put it as a 0 there, or I can even remove it there itself. I now need to find what c is. I need to use the first equation that we have here, which is a plus b plus c is equal to a 7. The value of A is a 2, value of B is 0. I need to find what C is. So 2 plus 0 plus C is equal to a 7. So I need to isolate C by bringing the 2 that I have in the left side of the equation to the other side. That makes it a 5. So this is the value of C. Now this can be written as 2n squared plus 5. This is the nth term of this quadratic sequence. So 2n squared plus 5 is the nth term of this quadratic sequence. So if I'm to find the fifth term, I need to do 2 times 5 squared plus 5. So when I do 2 times 5 squared plus 5, it will give us the value of the fifth term, which will be equal to 55. So I'm going to put that 55 here. So this is equal to 55. Now, just like we use the formulas here as 2a, 3a plus b, and a plus b plus c here, even for this first sequence that we have here, we could have used this arithmetic sequence formula, and the two formulas that you would be using is a and a plus b. 4 will be related with this a that we have here. This -7 will be equal to a plus b. That way we can find what a and b is and substitute it into this formula that we have. We can do it that way as well. There's no problem with that. We will still end up getting the same answer. Now let's move on to the next question that we have, which is question C, which is the sequence which is in the form of a fraction. Now, whenever we have fractional sequences, we need to do the numerators separately. We need to find the nth term for the numerator separately and the nth term for the denominator separately. So in this, the sequence is given as 2 over 27, 3 over 81, 4 over 243, and 5 over 729. I'm going to write the numerators separately as 2, 3, 4, and 5. So I can find the nth term for this sequence that I have here. It increases by a 1 each time. As it increases by a 1 each time, it will be plus n or plus 1n. So I can write it as plus n or just n, or 1n can be written, or I can write it as 1n. I'll just put 1 as well. So if, whether I put the 1 in front or not, it doesn't make a difference. Then the next thing is, from this one, I need to see how I can get to this n here, get to this 2 here. So I need to add another one to that. That will combine with this. So this n plus 1 is the nth term for the numerator. So I'm going to write that here on top, which is n plus 1. The nth term for the numerator is done. Now we do the same thing for the denominator as well. So the denominators that we have in this sequence is 27, 81, 243, 729. So in this case, each time the sequence, it increases, it does not increase by a fixed value. It gets increased by multiplying by a certain amount each time. So this has to be multiplied by 3, a 3, and a 3. So when 27 is multiplied by a 3, we get 81. 81 times 3 is 243. 243 times 3 is 729. Which means that each time as it increases by multiplying, each time as it gets multiplied by 3, we call this as an exponential sequence. To find the nth term of an exponential sequence, we know that it multiplies by 3 each time, so it's going to be 3 to the power n. But when we substitute 1 for n, it becomes 3 to the power 1, which is a 3. But we need to get our first term as 27. So to get the first term as 27, we need to add a 2 to this n. So only then 3 to the power 1 is 1 plus 2. So 1 plus 2 becomes a 3. So that is the same as 3 to the power 3, which is 27. So this 3 to the power n plus 1 is the nth term for the denominator. So I can write it as 3 to the power, not n plus 1, I'm sorry, n plus 2. So then this is the, this will be this expression that we have here is the nth term for this fractional sequence that we have. So I can write the nth term here as n plus 1 over 3 to the power n plus 2. So this n and plus 2, they are in the form of index. I now need to find the fifth term as well. So the numerator increases by a 1 each time, which means in this case, it's going to be a 6 over the denominator multiplies by 3 each time, which means this 729 also should be multiplied by 3. When we do that, I get 2187. So this will be my fifth term. With that, we are done with this question. Let's move on to the next part that we have, which is question B. In a sequence, the sum of the first 49 terms is 7,644. The sum of the first 50 terms is 7,975. We need to find the 50th term. The 49th term, the sum of all the first 49 terms is given. The sum of the first 50 terms is also given. The difference between the two will give us the 50th term. So 7,975 minus 7,644. This difference is going to be the answer, which is 331. Which means the 50th term is equal to 331. In question 7, we have a frequency table that is given of 42 athletes in a race. We need to calculate an estimate for the mean time. If we are to calculate the estimate for a mean when a table like this is given, we have to use the formula fx over f, which means the frequency has to be multiplied with x divided by the total of the frequency. And here the value of x is going to be, now here the value of x is given in the form of a group. So therefore, we need to find the mid value. So in this case, mid value will be the value of x. So to find the mid value, we need to add the two numbers given to us and divide it by 2 each time. So when we do that, we can, using that, we can complete the mid values here. So I'm gonna complete with the values here. So this will give us 219.5, 217.5, 217.5, 221.5, 224, and 234. If we add and divide by 2, we get 229. Then we have 239. And when we add 244 and 264, and when we divide it by 2, we get 254. That is the value in the middle of the two, the largest and the smallest and the largest values given in each of these class intervals. Now, if we are to calculate the mean, now the frequency has to be multiplied with the mid value that we have here. And then we need to divide it by the total of the frequency, which means this 217.5 should be times by 9, 221.5 times by 14, 229 times by 14 again, 239 times by 2, 254 times by 3. Add them all up, and we need to divide it by the total of the frequency. When we add these 5 numbers together, it will give us 42, which is already given to us in the question. So I can write it over 42. When we put this in the calculator, you get something like 226.2936. Likewise, it keeps continuing. So correct to one decimal place, I will write it as 226.3 seconds. Or else correct to 2 decimal places also, it will be 226.30 seconds, because you end up getting something like 226.2976. That is what you will end up getting. Let's move on to question B that we have here. In question B that is given, we need to complete the frequency histogram, the histogram that is given to us. In the histogram, always in the y-axis, we will have the frequency density. To calculate the frequency density, the frequency has to be divided by the class width. The frequency is given to us. We need to divide each of this frequency by the class width. The class width is the distance in between the two numbers that are given to us, the smallest and the largest number. And then we can calculate the frequency density. First, I'm going to add another column here so that it doesn't confuse us as class width. We will first calculate the class width for each of these class intervals given. Then we can calculate the frequency density. So here, 216 to 219, it's a 3. 219 to 225, we have a difference of 5. Then 224 to 234, it's a 10, another 10, and then we have a 20 here. Now, if we are to calculate the frequency density, because it's very important that we know the frequency density to draw the frequency histogram, the frequency is the number of athletes, that column has to be divided by the class width. That means this 9 has to be divided by 3. We end up getting a 3, that is the frequency density. 14 divided by 5 gives us 2.8. 14 divided by 10 is 1.4. 14, again we have 2 divided by 10, which is 0.2. Then 3 divided by 20, which is 0.15. So for each one of this, we have calculated the frequency density. Now here, the frequency density, so this value is given to us. So this is 200, and now here the value given to us is 216. This is 219. So 216 to 219, this one's frequency density is 2.8. So this same 2.8 is only given here. I'm sorry, not 2.8. We have 3. So 216 to 219 has a frequency density of 3. So that same frequency is only given here. That means all the others will have the same height. The height of the height and the frequency density is the same. But it will not be the same always in different questions. Now the height can be different as well. But here in this question, the frequency density and the height is the same. So the second one, which is from 219 to 224, has a height of 2.8. 219 to 224. So this is where 224 is, has a height of 2.8. So this is 3, this is 2.9. So this is where 2.8 will be. So we're going to draw it this way. This is what we get. The next one that we have is given to us as 224 to 234, it's 1.4. So 224 to 234 is going to be here. It has a height of 1.4. This is 1. So 1.4 will be here. So I need to draw it this way because this has a height of 1.4. Next we had 0.2, that was from 234 to 244. So it had a height of 0.2. So 1, 2, this is how it will be. And then the last one is from 244 to 264 with a height of 0.15. So 0.15 is already marked here. So this is how it's given to us. Then let's see what we have next. In question 8, this is a question related to volume of solids. So we have a hemisphere at the bottom, a larger one. There is a hemisphere at the top, a smaller one, and we have a cylinder in between. And this is a solid that is formed by combining all of these three shapes together. So then the first question is, show that the volume of the solid is 692 cubic centimeters, correct to the nearest cubic centimeter. So then in this case, to calculate the volume of this solid, the volume of this solid will be equal to the volume of the larger hemisphere plus the volume of the cylinder that we have in the middle of the two hemispheres plus the volume of the smaller hemisphere. So we need to add all these three together. This will give us the volume of the solid. To calculate the volume of a hemisphere, the sphere's formula is given to us. We need to divide that by 2. So when we divide this 4/3 by 2, 4/3 pi r cubed by 2. So if we just consider only the fraction that is given here, 4/3 when we divide it by 2, we get 4/3 times 1/2, which is the same as 2/3. So that is how we get the volume of the hemisphere as 2/3 pi r cubed. So I'm going to use that. So 2/3 times pi times the radius of the larger hemisphere is given to us as 5.4. So it's going to be this times 5.4 cube. plus the volume of the cylinder is found by multiplying the area of the cross section, which is pi r squared, with the height. So the radius of the cylinder and the smaller hemisphere is the same, which is 3.6. So then I need to do pi times 3.6 squared multiplied with the height of the cylinder, which is 6.5. Add this with the volume of the smaller hemisphere, it's going to be 2/3 times pi times the radius of the smaller hemisphere, which is 3.6 cube. We can put this in the calculator to find the volume of this solid. So then I'm gonna put this all at once in the calculator. So I have 2/3 pi r cube, which is pi times radius is 5.4 cubed. 5.4 cubed. I need to add this with pi times 3.6 squared times 6.5. Then add this with the volume of the smaller hemisphere, which is 2/3 times pi times, so pi times 3.6 cube. So I'm going to close the brackets and find the answer. So this is what I get in terms of pi, but this is the answer. So I get 692.1556934, but I need to write it correct to the nearest cubic centimeter. So correct to the nearest cubic centimeter will be 692 cubic centimeters. So I can write it as 692 cubic centimeters. This is what I get. So before getting to this answer, the answer that we had was 692 point something like 16. So that is what we have. When we round it to 2 decimal places, this is what we will have. So I'll write it as 155 itself. So this is what I had. And I had to write it to the nearest cubic centimeter. That is what it's mentioned in the question. So it's going to be 692 cubic centimeters. Let's move on to the next question that we have. In this question, given, a mathematically similar solid is made of silver in this solid. So the structure will be a smaller version of this or a larger version of this. That's what they're trying to say by this term, mathematically similar, by mentioning it as mathematically similar. Now, in this case, the radius of the cylinder is going to be 0.6. So previously, the radius was given to us as 3.6. Now, the radius of this cylinder will become 0.6. So if I just draw only the cylinders, so the original one has a radius of 3.6. Now, the new one is going to be thinner. It's going to have a radius of 0.6. And okay, so it will have a certain height. So from the radius, we can understand that this is going to be somewhat smaller in shape compared to this one, the original shape. So the original shape is this. Now, you need to calculate the total mass of silver solid, mass of this silver solid, and 1 cubic centimeter of silver has a mass of 10.49 grams. Now here, you need to find the volume of the new solid first. To find the volume of the new solid, we need to find what the linear scale factor is going to be. And then we need to use that to calculate the volume scale factor. That is how we find the volume of the new shape. So to do that, first I'm going to put the smaller sphere over the larger one. The larger one is the original one. I will write it this way. So it's going to be 0.6 over 3.6. So that is, I made use of the 2 radii. I wrote it in the form of a fraction to find the scale factor. So this will give me 1/6. So this is the linear scale factor. But I need to find the volume of the smaller solid that is similar to the original shape. So to find the volume, I need the volume scale factor. So I need to cube this amount. So when I cube this, I get 1/260. Now I need to find the volume of this new shape that is given to us. So I can write the volume of the smaller shape over the volume of the larger shape. That is the scale factor. I'm going to write it first as 1/216. This will be the same as the volume of the smaller shape is what we are supposed to find over the volume of the larger shape. From the previous question, this 692 centimeter cube that we got is the volume of the larger shape. Now I need to find the volume of the smaller shape. To find that, I'm going to cross multiply this and isolate V, or simply bring this 692 to the other side. So 692 gets divided by 216 to find what V is. So V is equal to 692 divided by 216. So when we do the division for this calculation, we end up getting an answer here. So let's find what we get. 692 divided by 216. This is what we get. So 3.204. Likewise, we get an answer. So I will write it as 3.204. 3.204. This is the volume in cubic centimeters. But they're asking for the total mass. Every cubic centimeter has a mass of 10.49 grams, means this one, to find the mass it will have, I need to times this by 10.49 to calculate how many grams this will be equal to. So I'm going to times 3.204, or else the answer that I got in the calculation, I'm going to times it by this 10.49. So when I do that, I get the answer as 33.6068. So correct to 2 decimal places, I can write it as 33.61. So 33.61 grams is the mass of the silver solid. That is the shape that is similar to this shape that is given at the top. Let's move on to the next question that we have. In this sector that is given to us, the angle is given to us as 316 degrees. We are supposed to calculate the length of the arc of this sector, and we need to make sure that we write the answer as a multiple of pi, which means we are expected to write our answer in terms of pi. When calculating the perimeter of a sector, we will have this arc length, we will have this radius and this radius as well. So it'll be angle out of 360 times 2 pi r plus 2r. But here it's not about the perimeter of the sector, but it's just the length of the arc. So we are supposed to calculate only the arc length. So in that case, we will use the formula angle out of 360 times 2 pi r. We do not add the 2 radius to it. So here the angle is 216. So we can write it out of 360 times it by 2 times pi times the radius, which is 10. So when we put this in the calculator, we will get the answer. But this time, I'm not going to put it with pi because I need to get the answer in terms of pi. So I'm going to put everything else without writing pi. So 216 over 360 times 2 times, I'm going to skip pi and then write 10. So when I do that, I get 12. Or even if I write it with the 2, then we will still, even if I write it with pi, I will get it in terms of pi. So if I'm to just show that, so 2 times pi times this will give me 12 pi as a decimal. Without pi means it's going to be 37.699. But in terms of pi means it's going to be 12 pi. So this will be equal to 12 pi. Therefore, this 12 pi is the answer for this question. Part 2. A cone is made from this sector by joining OA and OB together. So that is the radius of the radii of the sector that is given here are connected together. Both the radii are connected together. Calculate the volume of the cone. To calculate the volume of the cone, in this case, the radius in the sector will act as the slant height of the cone, because when we connect this portion and this portion together, the radius will be the slant height for the cone. Then this arc length of the cone will become the radius, will become the circumference of the circle, or will form the circle at the bottom. Now, if we are to calculate the volume of the cone, the formula to calculate the volume of the cone is given to us as 1/3 pi r cube. So it's going to be 1/3 times pi times the radius of the cone. So the radius of the cone is not known to us. I'm going to write it as r. So I need to find that r. And the height of the cone is also not known to us. I need to find the radius as well as the height. Now, in this sector that was given to us, so this is how that sector was given. The angle was known to us. So like I mentioned, this portion that we have here, these two radius will form this side of the cone, which means the radius was given to us as 10. The slant height of the cone is 10. So therefore, this slant height, this side also will be a 10. Now, the next thing is this portion of the circle, which is the sector, which is the arc length of the sector, will form the circle at the bottom. So that means from this, I can write it as the arc length of this sector is equal to the circumference of the circle. So in that case, the arc length, we already know, we got the answer as 12 pi, which is equal to the circumference of the circle. To find the circumference of a circle, we use the formula 2 pi r. Then I can isolate r to find the radius. So to do that, I need to bring this 2 pi to the other side. So this 12 pi has to be divided by 2 pi for us to find what r is. The radius, the pi and the pi will cancel out. 12 divided by 2 is a 6. So r is 6, which means the radius of the cone is 6 centimeters. So I can substitute it here. So r is 6, so I can write it as 6 squared. I need to times this with the height of the cone. So the height of the cone is what we need to find, because in this case, the slant height is only known to us. So to calculate the height of the cone, this is going to be the height of the cone. So we are going to make use of the Pythagoras theorem, because this side is 10, the same way, this side also will be the same 10. So we know that this is a right triangle. In this right triangle, 10, this is r, this is the height. The value of r we now know, that is a 6. So then if we are to calculate the height, we need to apply the Pythagoras theorem. So when we apply the Pythagoras theorem, in this case to calculate one of the shorter leg, we need to square the two sides, subtract it, and then we need to square root it. So in that case, to find what h is, I square 10, I square 6, find the difference and square root it. So when we do that, 10 squared minus 6 squared, I'm going to put this in the calculator. 10 squared minus 6 squared and square root will give me 8 as the answer. So then the height of the triangle, or the height of the cone here, is going to be 8. So then I'm going to substitute this height here. So now I can calculate the volume of the cone. So in this case, to calculate the volume of the cone, I need to multiply 1/3, 1/3. So we have 1/3. I need to times it with pi, times it with 6 squared, and then I need to multiply with 8. So I get 96 pi. Now in this case, we are not expected to write the answer in terms of pi. So we need to make sure we write it in the standard form, which is you can write it to 3 significant figures, or I'm going to write it as 301.59, which is correct to 2 decimal places. So here the answer is 301.59 cubic centimeters. This will be the volume of the cone that we have here. So with that, we will be done with this question. Let's move on to the next question that we have, which is question 9. Question 9 is a function question that we have here. So there are 3 different functions given to us. Question A1, we are supposed to find what f of 0 is. So we need to substitute 0 wherever you find x in the f of x function. So we have 3 times x, so it's going to be 3 times 0 plus 1. And then I have 0 plus 5. And then I have 0 minus 4. So I'm going to solve this. 3 times 0 plus 1 will be a 1. Times it with 0 plus 5, which is a 5. And then I need to times it with this minus 4. When I do that, I get minus 20. I now need to find the inverse function of g. Now, to find the inverse function when an expression is given to us, now here, g of x is given to us as 2x minus 3, and to find the inverse function, in that case, we need to do 2 steps. The first step is to make x the subject. Once when we make x the subject, we need to switch x and y around. Now here, y is going to be this g of x. So first what I'm going to do is, this g of x, instead of writing it as g of x, I'm going to write it as y is equal to 2x minus 3. Now, like I've mentioned in the first point, I need to make x the subject. So I need to bring the minus 3 to the other side. So it becomes y plus 3. This is equal to 2x. So if I'm to find what x is, I need to bring the 2 to the other side. The 2 gets multiplied with x. When I take it to the other side, it will get divided. So then to find what x is, y plus 3 has to be divided by 2. Now that I have x is equal to y plus 3 divided by 2, I need to do the second step, which is to switch x and y around. So I'm going to switch them around. So y is equal to x plus 3 over 2. So this x plus 3 over 2 is equal to the inverse function that we have here. The next question is to find what g of h of 2 is. That means in this case, first you need to find what h of 2 is. Once when we find h of 2, that is going to be substituted for x in the g of x function. That means first we need to find what h of 2 is. To find what h of 2 is, it's going to be 4 to the power 2 times x. So 2 times the value of this h, which is 2. And I need to deduct 1 from this. So 2 times 2 is 4. 4 minus 1 will be equal to a 3. So that's going to be 4 to the power 3. So I need to see what 4 to the power 3 is. 4 to the power 3 is the same as 64, which means h of 2 is 64. This answer is the input for the next function, which is g of x. Now that means it's going to be g64 is what we are supposed to find, which means here the function is 2x minus 3. So it's going to be 2 times the value of x, which is 64. And I need to deduct a 3 from this. So when I do this, I get 125 as the value, as the answer for this function, which is g of h of 2. Let's move on to the next question, which is g2x is equal to 7. Now here g2x is equal to 7 means first I'm going to find what this g2x is equal to. So this means 2x is the input for the gx function. So the gx function is 2x minus 3. So here this x has to be substituted with this 2x, which means it will be 2 times 2x minus 3, which is equal to 4x minus 3. This is what we have. This is equal to this 7 that we have here. So then I can say 4x minus 3 is equal to this 7. Now I need to find what x is. Take the minus 3 to the other side, that becomes plus 3. So 4x is equal to 7 plus 3, which is a 10. And then I need to find what x is. I need to divide this 10 by a 4. So when I divide the 10 by a 4, I end up getting 2.5. So then this 2.5 is the value of x. Let's move on to question C. In question C, I need to find what g of x squared is, which means x squared is the input for the g of x function. So the g of x function is, and with that we need to add g of x plus 1. So first I need to find gx squared. To do that, the input is going to be x squared. So the function that we have is, for gx that we have is 2x minus 3. So this x has to be substituted with x squared. So this becomes 2 times x squared minus 3. So this is the answer we get for gx squared. Now the same way, I need to find what g of x is equal to. That means this g of x is substituted, the answer for g of x is substituted into x in the g of x function. That means First, we are going to write the g of function again. So we know that it's this 2x minus 3. So this x is replaced with this function g of x. So that means the function for g of x is also 2x minus 3, which means this x is replaced with this 2x minus 3. So this is equal to 2 times 2x minus 3 minus 3. So when we solve this, we're going to multiply this 2 times 2x, which is 4x, 2 times minus 3, that is minus 6, and then we have another minus 3. When we simplify this, we get 4x minus 9. Now what we got to do is the two answers that we got here for gx squared, which is this one, and 4x minus 9 should be added with this one. So 2x squared minus 3 plus 4x minus 9 should be added with this one. Now I need to simplify this. So when I simplify this, I get 2x squared, and I have this 4x. I have minus 3 and minus 9, which is minus 12. Minus 12 and 1 is minus 11. So the answer is going to be 2x squared plus 4x minus 11. Let's move on to the next question that we have, which is question D. In this question that is given to us, H inverse is given as 16. That means we need to make use of the inverse function of H to work this one out. Now, in the question that is given to us for the inverse function of H, we are given 4 to the power 2x minus 1, which is an exponential function. But for this exponential function, to do the inverse of this exponential function is going to be slightly difficult, because we have an inverse, we have an index that is involved. We can do it using logarithms, but logarithms is not in the IGCSE syllabus. So due to that reason, we cannot use that. So I'm going to use a function machine, a diagram, to explain how this is done. So when we consider a function machine, in this case, if we send in an input, if this is the input, we will have the output on the other side. So if I send in x as the input, for this function, which is h of x, the function is given as 4 to the power 2x minus 1, which means this x that we have here gets replaced with this input that I'm going to send. And so I will get the output. So in this case, my output will also be this 4 to the power 2x minus 1. So if I send in 1, this x gets replaced with 1, and then I'll get the output. But in this case, I'm going to send in x. If I send in x, this is the same output that I would receive. The inverse function is going to be the opposite of it. Now, in the question, for the inverse function, you're going to send in 16 as the input, which means in the inverse function, the output will act as the input, which means we are sending in 16 here, and we are trying to find what is going to be the output. So then, to do that, in this case, we can do it this way. Now here, the 16 is the output, as this 4 to the power 2x minus 1. So I can equate those two. 4 to the power 2x minus 1 is equal to 16. Then I can write this 16 in the form of an index by writing it as 4 squared. So 4 to the power 2x minus 1 is the same as, is equal to 4 squared. Now I clearly know that this and this are the same. They are equal bases. Their bases are equal, which means the indices will definitely become equal, which means I can say that this 2x minus 1 is equal to a 2, and I need to make x the subject. So I need to take the minus 1 to the other side. It becomes plus 1. So 2x will be equal to 2 plus 1, which is a 3, which means if I'm to find what x is, I need to divide the 3 by a 2. So it gives me the answer 1.5 as the value for x, which means for this 16, which is the input, the output that I get using the inverse of it will be 1.5. Now, if I'm to explain it the other way around, it's like if you send in 1.5 inside the function machine, we will get an output of 16. We did the reverse of this to find what was that original number. So in this case, it's going to be 1.5. That is the answer. Let's move on to the next question that we have. So we have 3 brackets here. We need to write it in the form ax squared plus bx squared plus cx plus d and identify what a, b, c, and d is equal to. So in this question, the 3 brackets has to be multiplied together. So I'm going to multiply the second bracket and the third bracket first. I can multiply the first and the second or any 2 brackets first, but I'm going to multiply the second and the third bracket. So x times x is x squared. X times minus 4 is minus 4x. So 5 times x is 5x. 5 times negative 4 is negative 20. So this is what I get. I can combine the like terms that I have here, which makes it x squared plus x minus 20. Now, with this answer, I need to multiply this bracket that I have here, which is 3x plus 1. So I'm going to expand them together by multiplying. So I'm going to multiply 3x and x squared, which is 3x cubed. 3x and this plus x should be multiplied, which is 3x squared. 3x times minus 20 is minus 60x. 1 times x squared is x squared. 1 times x will give us x. And 1 times negative 2 is negative. 1 times negative 20 is negative 20. Now I can combine all the like terms that I have here. So that will give us 3x cubed. 3x squared and plus x squared is the same as 4x squared. Then I have minus 60x and plus x, which is minus 59x. And then I have minus 20, which means 3 is the value of a. This plus 4 is the value of this b that I have here. So I'll underline it. So this is 4. And c is the value of this minus 59. C is equal to minus 59. And d is equal to this minus 20. So this is how we work this out to find what a, b, c, and d is equal to. Let's move on to the next question that we have. In this question, ABC is a triangle. So the coordinate of point B and the coordinate of point A is given to us. And C to A is negative 11 or 11, 8. That is how it's given. So this is given as a column vector. So we need to find the coordinates of point C. So to do this question, I'm going to draw a small sketch in the side, because when we draw that, it makes it easier for us to understand what's really happening. So in this diagram, in this sketch that I'm gonna mark the information that is mentioned in the question. So point B has a coordinate of 1 and negative 10. So 1 and negative 10, maybe it's going to be somewhere over here. This is point B. I'll just mark negative 10 here and 1 here. And then the next one is point A, which is 4 and 14. So 4 and 14 will be somewhere over here. So I'll just mark 4 here and 14 here. This is just a small sketch. And the next one is C to A is given to us as negative 11 to 8, 11 and 8. C to A is negative 11 and 8 means I can find what I can say A to C is in the opposite, the same values, but in the opposite direction. It will be positive 11 and negative 8. That means from A to find the location of C, it has to go 11 units to the right. So from here, it's going to go 11 units to the right. And then it's going to go down by negative 8. Down negative 8 means it's going to go down by 8 units. So I'm going to just mark it this way. So somewhere over here. This is the location of C. So C to A means from C to reach this A, it's going to go 11 units to the left and then 8 units up. That's the meaning. So this is where point C is. Now the question is to find the coordinates of point C. To find the coordinates of point C, from A, I can find what C is. So it's going to be 11 units to the right. So if we consider the value of x for point A, which is 4, with that to that 4, I need to add 11 more units to the units, because it's going to be 11 units away from that point A. So that's going to be 15. the same way, the x coordinate of this will be 15 then. And then I need to find the y coordinate of point C. So it's 8 units below A. A is at 14. So 8 units below means I need to subtract 8 from this 14, which is a 6. So then this point is at 15 and 6. That is the meaning. So the coordinates of point C is 15, 6. The next question is to find what B to A is. So we can make use of the diagram that I have drawn here to find what B to A is. So from here, you're going to see how to reach A. Or else there's another way to do by using this method that I have mentioned in the right side. So that is when it's given as B to A, first, the meaning of this is from the coordinates of point A, you need to deduct the coordinates of point B. Now here, the coordinates that we have for point B is given to us as 1 and negative 10. And A is given to us as 4 and 14. So from A, I need to deduct B. So B to A means from A, I deduct B. A to B means from B, I deduct A. So now when we consider the x values, I have 4 here. So from 4, when I deduct this one, I get a 3. That goes to the top. From 14, I need to deduct this 10. So 14 minus 10 is the same as 24. So previously we had to do 4 minus 1, which is a 3. Here it's going to be 14 minus 10, which is 24. So that is the number that goes to the bottom. So this is how we write it in the form of a column vector. The next question is to find what C to A is. To find what C to A is, it's going to be this length that we are supposed to find. This length, the length of this line. So we need to find the modulus of C to A, which means we are simply asked to find the length of C to A. So to find the length of C to A, we are going to complete this into this is a right angled triangle. So we are going to apply Pythagoras' theorem to calculate the modulus of C to A. So this side is 11, this side is 8. So we square 11 and 8. It's like we're trying to calculate the hypotenuse, which is CA. We need to add them and square root the answer that we get. So when we put this in the calculator, let's see what we get. The square root of 11 squared, I need to add that with 8 squared. So when I do that, I get square root of 185 as the answer. That is the exact answer. But in the form of a decimal, it's going to be 13.6. Correct to 2 decimal places or even 1 decimal place, it's the same thing. So 13.6 correct to 1 decimal place. If we write it correct to 2 decimal places means we will add another 0 to it, because after the 0, we have a 1 in the question, in the answer. So then with that, we are done working out this part of the question. Let's move on to the next part of the question. So question B is a question, is a vector related question. So we need to show that O to R is 2/5 A plus 3/5 B. And in the question, it's mentioned that R is a point on M to N. And the ratio between M to R and R to N is given to us as 3:2. And this line ORT is a straight line. So we are supposed to find what O to R is. So that is going to be from here to here. This is what we are supposed to find. First, I'm going to find what M to N is. So if I'm to find what M to N is, I need to go from M to O and then O to N. So M to O and then O to N. That is the route I have to take. So O to M is A. So M to O will be negative A. With that, I need to add O to N, which is B. So this is going to be M to N. Now I need to find M to R, and then R to N. So I have a total of 3 portions and 2 portions, which makes a total of 5 portions. Which means M to R will be equal to, out of 5 portions, when we add the 3 and the 2, it makes 5. It's going to be 3 portions. So 3/5 of M to N, which is negative A plus B. So I can write this as negative 3/5A plus B. So I can just leave it like that, or I can solve this and write it as negative 3 over 5a plus some positive 3/5 b. So that is, I'm simply multiplying this negative a and positive b with this 3/5. Now the question is asking us to find what O to R is. So to find what O to R is, I'm going to take this root, that is from O to M and then M to R. So O to M and then M to R is the root that I'm going to take. So in this case, O to M is given to us as A, and M to R is the vector that we found here, which is minus 3/5 A plus 3/5 B. Now I'm going to simplify this by combining all the like terms together. So in this case, I can combine A with this negative 3/5 A. So A has a whole number of 1 in front. That means both the numerator and the denominator will be 1 and 1. I can multiply both by a 5. So it becomes 5 over 5. So 5 over 5 and this negative 3 over 5 is the same as 2 over 5A. And I need to add 3/5 B to this. This is only equal to O to R. So we have got the same answer as given in the question. So when they ask us to show, we need to prove as to how we can get to that answer. Let's move on to the next question that we have. So question 2a. In this question that is given to us, n to t is given to us as 4a plus kb, and O to t is given to us as c times O to R. So in the question, we need to find what this k and c is. Now, we already know what O to R is. Now, we need to find what O to t is. So we know that O to R is given to us as, I'll write it here. So O to R is this 2/5 A plus 3/5 B that we found here. And we are supposed to find what O to T is. I'm going to find what O to T is because they have formed a relationship between O to T and O to R. So to find what O to T is, it's going to be from here to here. So that is from here to here, O to T. That's going to be the same as O to N and then N to T. So I can take this root to find that. In this case, if we are to do it, O to N is given to us as B. So O to T is from O to N, and then I can write it as N to T. So O to N is already known to us in the question, which is B, and N to T is already given to us in the question as 4a plus kb. So I'm going to write it here, 4a plus kb. This is equal to O to T. We also know that O to T is given to us in the question as C times O to R, which means I can write it as C times O to R. We already found what O to R is in the previous question, so I can write it as 2/5 A plus 3/5 B. This is only equal to O to T. Now, what I'm going to do next is I'm going to expand this. So I'm going to multiply this 2/5 A with this C, this 3/5 B with this C again. So when I do that, I end up getting 2/5, I'll write it as CA, but this C is a number. It can be a whole number or it can be a fraction. With that, I need to multiply this as well. So it's going to be 3/5 CB. Now, this is equal to O to T as well. Now, we have formed two relationships that explain what O to T is. So I can equate these two together. So when I equate these two together, so in this case, I can write it as this O to T is the same as, I can write it as 2/5 CA plus 3/5 CB is equal to B plus 4A plus KB. I'm going to combine all these. I'm going to form a relationship between these A's. So that is, these two will be equal to each other because in the end, the value of C is a whole number, or it can be a fraction. That is what we are supposed to find. So 2/5 CA is equal to 4A. So I can cross out the A's in both. So if I'm to find what C is, I need to bring this 2/5 to the other side. The denominator goes to the other side, it gets multiplied. So 4 times 5, and the 2 gets multiplied. When I take it to the other side, it will get divided. So when I solve this, I get C is equal to 4 times 5, that is 20. 20 divided by 2 is a 10. So then the value of C is equal to a 10. The same way, I need to find what K is. To find K, I'm going to make use of this one, or everything that has K in it. That is the B's. I'm going to relate all the B's. So this, and this one. So I can say that 3/5 CB is equal to this B that I have here, plus this KB. They all have B in common. So I'm going to cross out the B's. So then I will have 3/5 C is equal to B, means there's a 1 there, 1 plus K. I also know the value of C from this step, that is C is a 10. So I'm going to substitute the value of C as a 10. So it will be 3/5 10. That is going to be 30/5. So 30/5 is equal to this 1 plus K. So then 30 divided by 5 is the same as a 6. So 6 is equal to 1 plus K, which means if I'm to find what K is, I need to bring this 1 to the other side. That will get deducted, which will make a 5, which means the value of K is a 5. So here the value of C is a 10 and K is a 5. I'm sorry, I did not have enough space here. That's the reason why I wrote it this way. So we will be able to manage it if I had started somewhere over here. Okay. Anyways, the value of K is a 5 and the value of C is a 10. This is what we get as the answer. Let's move on to the next question that we have, which is to find M to T. So if we are to find what M to T is, so this is where M is, this is where T is. I need to find what M to T is. It's going to be this. I'm going to take the root M to O to N, and N to T. So M to T is the same as M to O to N, and then N to T. M to O will be minus A, and then O to N is plus B. So I can write minus A plus B, and then I have N to T. So N to T, that is going to be from here to here. That will be equal to, now I know the value of what I called K and the value of C as well. So I can find what N to T is. N to T is equal to 4A plus 5B. The reason why it's 4A plus 5B is, so from this step that we have here, we know that N to T is this 4A plus KB. We know the value of K, which is a 5. So I'm going to put that here. So it's 4A plus 5B. So that's how I got what N to T is. Now I need to combine them together and see what I get as the value for M to T. So when I do that, I get 3A plus 6B as the answer for M to T. So 3A plus 6B is the answer. Let's move on to the next question that we have, which is question 11. This is a differentiation question. So first you're supposed to find the differentiation, that is the derivative function of this expression that is given to us. So to do that, the index that we have for x has to be multiplied with the coefficient of that x. So there is no coefficient, means there is a 1. So you need to multiply the 1 and the 3 together, which is a 3. Then I put this x and reduce the index of x by a 1. So it becomes a 2. So I need to put that 2 here. Then I have the 2 here in this x square, in this x. I need to times that with the coefficient. The coefficient is -4. 2 times -4 is -8. So I'm going to write -8. And then I have x, and the power 2 has to be reduced by 1, which is 2 becomes a 1. So that will be a 1. So it's going to be just 8x. And then Here the power of x is 1, as there's no power. I need to times that with this number in front, which is -3, the coefficient of x. So 1 times -3 is -3. So -3, and the power of x is reduced by 1. So when I reduce the power of x by 1, it becomes a 0. So x to the power 0 will be a 1 anyways. So I'm just going to leave it as -3. So then, because -3 times x to the power 0 is a 1, means a -3 times 1 will be a -3. So this is the derivative function that we get. Now, the next question is, a curve has an equation of y is equal to x cubed minus 4x squared minus 3x. We are supposed to work out the coordinates of the two stationary points, showing all your working. So now, the moment we see the term stationary points, we need to understand that stationary points are the points where the gradient is always equal to a 0. Sometimes these stationary points, they would have mentioned it as the maximum point, the minimum point, or the turning point as well. But they all mean the same thing. At those points, the gradient is 0. And this derivative function, which is this 3x squared minus 8x minus 3, is a formula that is used to calculate the gradient. So this is the gradient formula. That's the meaning. So we call it as the derivative function, but actually this is the that means it's the formula to calculate the gradient. So in this case, now the gradient is equal to 0 means we need to make this derivative function that we found in the previous step equal to a 0 and solve to find what x is. So I can say this 3x squared minus 8x minus 3 is equal to a 0 because the gradient is equal to a 0 when we have stationary points. We need to solve this to find what a, b, and c is. I'm going to make use of the formula method to solve this. So in this case, the value of a is 3. The value of b is -8. C is this -3. And I'm going to substitute this into the quadratic equation. So the quadratic formula, which is minus b plus minus the square root of b squared minus 4ac over 2a. I'm going to substitute the values here. I have minus 8, which is a plus 8, but I'm going to write it the same way like that. And b is again -8. So I'm going to put the brackets when I have a negative number for b. And then minus 4 times the value of a, which is 3 times the value of c, which is -3. So I may skip the brackets here. That wouldn't be a problem. But definitely this bracket for the negative for b is very, very important. We have to put it. So then if not, it can confuse you. That's the problem. So then 2 times the value of a, which is a 3. So I'm going to put this in the calculator. And this time I need to make sure I get 2 values for x. That is because of this plus minus sign. So I'm going to first put it with the plus sign and see what I end up getting. So I have minus 8. I'm going to put the plus square root. And then within the brackets, I'm going to write -8 squared minus 4 times 3 times -3. And then I need to divide it with 2 times 3, so which is equal to a 3. So I get a 3 here as the positive answer. I do the same thing for the negative. So I'm just going to move the cursor around. And instead of this plus, I'm going to change the plus into a minus now. So when I do that, I get -1/3. So this is the answer that I get. So the value of x is -1/3. We can find the value of x using completing the square method as well as by using the factorizing method as well. There's no problem with that. But the factorizing method will not work for all the questions. So we can make use of the formula method, which is much more easier. Now that we know the values of x, for these 2 values of x, we need to find their respective y coordinate. So to find that, we need to substitute this into the equation, the original equation, the equation of the curve to find what y is. So then the equation of the curve is x cubed minus 4x squared minus 3x. So y is equal to x cubed minus 4x squared minus 3x is the equation of the graph. So we're going to substitute the value of x here. So it's going to be 3 cube minus 4 times 3 squared minus 3 times 3. I need to find the value for this. The same way, I'm going to find the other value for y. So the other value for y is when I substitute the value of x as negative 1/3. So it's going to be negative 1/3. I'm going to cube it minus 4 times negative 1/3 square minus 3 times negative 1/3. So this is what I get. I'm going to find the answer for this one as well. So I'm going to put both in the calculator. So I have 3 cube minus 4 times 3 squared minus 3 times 3. I get the value as minus 18. So then I get minus 18 as the answer for y. And then the next value that I have is minus 1/3 minus 1/3. I need to cube this. So I'm going to cube it. And then I need to deduct minus 4 times. And to put minus. And I have the fraction here, 1/3. Close the bracket. Squared. Minus 3 times minus 1/3 is what I have. So I'm going to put that 1/3. Close the brackets, and the answer is 14/27. So then the coordinates is going to be 3 and negative 18, negative 1/3 and 14/27. So these two are the coordinates of the turning points or the stationary points. Let's move on to the next question then. So that's the last part of this question that we have here. So in this question that is given to us, we are supposed to determine whether each stationary point is a maximum or a minimum, is a maximum point or a minimum point, and we need to show our workings. Okay, now we got the two coordinate points previously. The two coordinate points that we got was 3 and negative 18. And the next coordinate point that we got was negative 1/3. And we got 14/27. These two were the coordinate points that we got. And what we're going to do is to identify which one is the maximum and the minimum value. What we got to do is I'm going to do a small sketch. The sketch will explain it all. So 3 and negative 8 will be somewhere over here. 3 and negative 8 is going to be somewhere over here. The same way, negative 1/3 and 14/27. So negative 1/3 means somewhere like this. It's going to be somewhere over here. And 14/27 is like 0.5. So that's going to be somewhere like this. So out of these 2 points, we need to identify which one is the minimum and the maximum. So here the equation for our curve was y is equal to x cubed minus 4x squared minus 3x. That is what we had. So this is a cubic graph, which means a cubic graph will have a maximum point here, and the minimum is going to be like this. So it's going to be something like this. This is how the graph will look like. So that is how we know that this is the maximum and the minimum point. So this point that we have here, which is this negative 1/3 14/27, is the maximum point. And then this is the minimum point. So this is the minimum coordinate point. So this is how we identify. So for this sketch, we will get a mark, and for mentioning which one is the maximum and the minimum, we will get a mark. Or else we can describe this in words. We can like explain it in words. Even that should work. Okay, that will not be a problem. So with that, we are done with all the questions that we have in this paper. So we will meet in the next paper.